This is a video on sequences, with a focus on linear sequences that are found in shapes and visual patterns. So here's our first example. So in this example, we see a pattern made from K'NEX pieces, and I've drawn the first three patterns in the sequence. So have a look at these, and then what I'd like you to do is to draw the fourth pattern. So pause the video here now while you do that. So I've started making the fourth pattern here, but I'm not quite finished. To finish it off, I need to add on 2 more pieces. Now I want to record the pattern or sequence generated. Generated just means made. So I want to make a record of the number of K'NEX pieces in each of the individual diagrams that have been created in this pattern. I've got 4 diagrams in this pattern so far, so I'm going to call those T1, T2, T3, T4. So term 1, term 2, term 3, and term 4. And then underneath that, I'm going to record how many pieces were in each. So if we look back to the first one, there were 1, 2, 3 pieces. And then in the second, 1, 2, 3, 4, 5. And we'll count the rest as well. There were 1, 2, 3, 4, 5, 6, 7 in the third. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 in the fourth. Next, I want to find the general term that describes the number of K'NEX in any diagram of the sequence. So this is just a question of finding Tn. We've looked at this in a previous video, so you may remember that the structure of Tn for linear sequence is Mn plus C, where M is the first difference and C is term 0. So we'll go to our recorded pattern and we'll work out both of those pieces of information. First of all, we want to look for the term-to-term difference, or the first difference. So how do I get from each term to the next? Well, I'll get from 3 to 5, and then 5 to 7, and then 7 to 9. I can clearly see that I have to add 2 each time. Remember, the fact that I have a common first difference here indicates that I do have a linear sequence. Next, I want to find term 0. So I'm just backtracking through my pattern. So 9, 7, 5, 3, this will be 1. And I can just double check that my first difference does the job to get me from term 0 to term 1. And yes, it does, because it's the same difference to get from 1 to 3 as it is from 3 to 5 and so on. It's still plus 2. So it's very straightforward now to make Tn our general term. Tn will be equal to, well, M is my first difference. I can see that's 2. N goes next, and then plus C is just my term 0. And in this case, I can see that the term 0 is 1, so plus 1. Okay, next I want to know how many K'NEX would I need to make the 10th diagram. Pause the video here yourself for a second while you try to work this out, and try to use the Tn to help you get to your solution, and then play and see if you're correct. Okay, so if I want to get the 10th diagram, the number of pieces in it, I'm going to use Tn and I'm going to replace n with 10. And that means that I'm going to replace any of the n's in the calculation with 10 as well. It's important to remember to put a bracket around any of those numbers that you substitute in. And then we go to the calculator, or you can do it in your head, and you can see here that this works out as 21. So I'd need 21 K'NEX to make the 10th diagram. Finally, I want to know for which diagram in the sequence would I need 37 K'NEX pieces. So first of all, I'm going to make a note of the general term. Now, I don't know which diagram requires these 37 pieces, so I don't know what number to put in for n. I do know, however, that when I put in if I had the n value and put it in, and I calculated out my answer, I'd get 37. So 37 is the term value. So I allow my general term equal to this term value. And that will then allow me to work out the term number n. So now I need to solve this equation, and then I'll know what the n is, and that will tell me which diagram would require that many pieces. So this is an easy one to solve. I leave the 2n on the left where it is. 37 is already on the right. Plus 1 is going to come across and it's going to subtract. I can simplify at this stage, and that will give me 2n equals 36. And then I can solve for n by dividing 36 by 2, and I get n equals 18. So if I was to continue on until the 18th diagram, I'd need 37 little K'NEX pieces to make that image. Questions involving diagrams are just like questions where you have the sequence listed out in front of you. The only difference is that you should always start by recording the pattern or sequence that is generated. So even if they don't give it to you as a list, if they give it to you as a set of diagrams, you should write down yourself, T1 is however many pieces, T2 is whatever, T3, and so on and so forth. And this makes it much more accessible then in terms of being able to find Tn, because you can write in your first difference and you can write in your T0 at the start. So even if they give you a diagram, even if they don't ask you to list out the values, make sure to start off by doing that.